Hi, I'm Paul Zachlin, one of the authors of your textbook, and I am here to help explain iterative methods for solving systems of linear equations. I'm going to help you use a spreadsheet today. I presume you've already done the GeoGebra exploration up above, where we show you, actually, this is the Gauss-Seidel method at work. And after 3 iterations, we're starting to converge to the actual solution to this system of equations, 5x minus 2y equals 10, x plus 3y equals 36. The actual solution is, as you could verify, 6 comma 10, which solves both equations. And we're getting pretty close to that after 3 iterations. But we're going to go ahead and implement both the Jacobi method and the Gauss-Seidel method on a spreadsheet. So the link is right here. One piece of advice I'll give is when you click on these links, if you right-click, you can open the link in a new tab. The advantage of that is I'll have the book in one tab and I'll have the spreadsheet available in another tab. Now, you'll notice that there's this green button that says this is view only. I would like to be able to edit the spreadsheet, and eventually, after I log into Google, I'll be able to make a copy. Notice it's grayed out right now. So we need to sign into Google. So I'm going to go ahead and do that. After I sign into Google, then I'll make a copy and I'll be all set. I can then edit the spreadsheet. I have to sign in first. So it signs me in. And now here I am, Jacobi's method and the Gauss-Seidel method. And I'll click on File and make a copy of this spreadsheet because I'd like to be able to edit it. Okay. Copy of Jacobi's method. And so that's the one that we'll use. Something we can edit. I can even close this other one out. Okay. So what is going on here is we are solving a system of the form ax plus by equals r, cx plus dy equals s. You could see the system over here in gray. And you'll notice it's exactly the same system that I used for the GeoGebra, at least when you logged in. 5x minus 2y equals 10 and x plus 3y equals 36. So we know the answer, 6 comma 10. But what I thought I'd do is walk you through how these two methods work. So let's scroll up to where I explain Jacobi's method. And you'll notice that we take the system of equations, and in the first equation, if we solve for x, we get the formula x equals 10 plus 2y equals 5. The second equation, I solve for y. We get y equals 36 minus x over 3. And what we're going to do is we're going to use these formulas in our spreadsheet. And that's how we'll move from the initial point, 0, 0, to the next point. It's going to end up being 2, 12. Let's see why that is. So if I click on the 2, and if I click up here, I can see the formula. The formula says L1 minus J1 times B7 all over H1. H1 is the 5 up here. We're dividing by 5. Well, you can see that because in the formula, notice we divide by 5. The formula says 10 plus 2y in the numerator. Let's see where that is in the formula here. L1, that's my 10. Now where do we get the plus 2y? Well, it says minus j1, minus negative 2 is the plus 2, times b7. Notice that b7 is the initial y value. And the other thing you'll notice are these dollar signs. And there's a reason you put dollar signs in a spreadsheet. It's so when you copy formulas from one to the next, the thing right after the dollar sign doesn't change. So you notice that the L doesn't change, the J doesn't change, the H doesn't change. The only thing that changes is the B. And let's see how that works. I'm going to press Escape.
So if I move one space to the right, I'm on cell D6. And I get, if I look at the formula there, it's still using the 5, the negative 2, and the 10 from the first equation. The only thing that has changed is now we're multiplying J1 by C7, which is the y value that I computed in step 1. And so what you can do is you can take these two formulas and I'll right click and I'll choose copy, which is Control C, paste is Control V. And what I'll do is I'll copy these two formulas to the right. Now you notice I already did these 3 cells, but you can go all the way to 10 or 11 iterations. And so I'll hit Control V, which will paste those formulas in. And the only thing that changes as you move to the right is the C7, the D7, the E7. We're always using the previous Y value to compute the current X value. And similarly, if I want to know what the Y value is doing, the only thing that's changing is the current X, the previous X value. So like this one uses the X value from step 4 to compute the Y value for iteration 5. So that's how Jacobi's method works. And again, the whole point is it uses these two formulas. Now, for the Gauss-Seidel method, you use the exact same formulas as before. You solve for x in the first equation, you solve for y in the second equation. The difference is that this time we're going to use them in succession. So I'll still compute x equals 2, as I did before. But you'll notice that the y value ends up being different. And the reason for that has to do with this staggering. You'll notice that I'm not going to use the 0 to get a 12. I'm going to use this value of 2 that I computed. And so my y value will become 11.3333 earlier. It'll become that at the end of step 1. And so what I can do is I can do the same thing. I can copy these formulas to the right. So by hitting Control C and then Control V for paste. And you'll notice what happens is we converge more quickly to the solution. So by the time I'm at step 4, after 4 iterations, I'm within 1/1000th of the actual solution. Well, maybe not quite, but close. Definitely by the time I'm within 5 iterations, I'm within 1/1000th. Whereas to get that close using the Jacobi's method, I have to go all the way to about 10 iterations. So there's a couple things I like about studying these iterative methods. Iterative methods are used all over scientific computing, mathematics, the other sciences. This gives you a flavor for what those are like. We will study more iterative methods later in the course when we talk about something called eigenvalues and eigenvectors. And this is just a really nice introduction to the subject that I think is pretty intuitive. I hope this video helped you and that you enjoy the rest of the section.